Hello, this is Dan Alford with Specialties. Today we're talking about analogous thinking in a wicked world. To demonstrate what I mean by that, we're going to show you three different projects which are very different but have one similarity. We're using tactile probes for part registration. Before a robot can do any useful work on a part, the robot must know where that part is relative to its origin. One way to do this is with tactile probes. It's a very accurate process, particularly in this first case. We're using a Renishaw probe with an RF link to determine the position of an armored vehicle prior to drilling and tapping. The term wicked world is coined by David Epstein in his book Range, which I recommend. Epstein writes that in a wicked world, feedback is either delayed or hard to understand or completely absent. In these environments, a generalist does better than a specialist. A generalist reapplies analogous thinking from other solutions to the problem at hand. The concept of a wicked world is in direct contrast with Malcolm Gladwell's thesis in his book Outliers. In Outliers, Gladwell says, when you have feedback that's quick and understandable, as in sports and such, 10,000 hours of repetition will make you an expert. The world that Malcolm Gladwell writes about is called a kind world, with plenty of feedback, where you can apply solutions that you've already worked out for problems that you've already seen. That doesn't even remotely resemble my world. In my world, we're constantly faced with new problems. In this case, we're trying to register a human femur and tibia in real time in the operating room to determine the position of the knee prior to orthopedic surgery with a robot. We're using the same tactile probe technology, but instead of a Renishaw, we're using feedback directly from the robot. So this is a great case of analogous thinking to find registration of a part. So the third example is just in the prototyping stage. So this is a virtual robot probing a virtual part. What this is a casting. Castings are notoriously inaccurate, and before we cut the risers and sprues off a casting, we need to register that part. And so using analogous thinking, we're using the same technique that we used both on human knees and on armored vehicles. So this third example might look more like the armored vehicle example I started out with, but from our perspective, it's more like the knees, because castings and human knees both are very irregular. The beauty of the armored vehicle, it was a flat plane. That's why we started out with that. 3 points define a plane, but in order to define a complex curve, you need to take multiple points. So we're actually using the same software that we developed for the human knees and applying it to this casting approach. So if you're trying to solve problems which have never been solved before, then you too need to become a generalist and start using analogous thinking to apply proven solutions to new problems. What do armor, surgery, and castings have in common? Very little, except they all require part registration, and in all three cases, tactile registration was the way to go. The team at Specialties is well versed in analogous thinking. At Specialties, we thrive on problems. Send us yours.